Everyone, this video is an exercise 11K question 1, which is in modeling with differential equations. So, the rate of increase of a population P of rabbits at 20 years is given by dp by dt is equal to kp, where k is a constant, and initially the population size was 200. This is very important. In part A, we want to solve the differential equation. So, we obviously need to use separation of variables, so we can multiply both sides by dt first, and that gives us dp is equal to kp dt. And now let's divide both sides by p, so the equation becomes 1 over p dp is equal to k dt. So remember that k is just a constant, and now we can integrate both sides. So the integral of 1 over p is len modulus p, but since p is population and population is positive, we don't need modulus. And the integral of k with respect to t is kt plus c. C is the constant of integration. Now remember that in part A, we want to find the value of the constant, because the equation has a giving p in terms of k and t, so we need to find the value of c. And we can use the fact that initially the population size was 200, so that means that when t is equal to 0, then p is equal to 200. So we have this information. Now we just need to substitute that. So that means len 200 is equal to basically 0 plus c, so c is len 200. Therefore, our equation is basically len p is equal to kt plus len 200. So that's just the value of c. Now, since the equation has to be basically in terms of k and t, which already is, but we can just do e to the power of both sides, so that this becomes easier. So we'll have basically e to the power of len p is equal to e to the kt plus len 200, and that is equal to p is equal to basically 200 e to the power kt. Right, in part B, so the value of k is equal to 3, and we want to find the time taken for the population to reach 4,000. Right, so for part B, we first substitute the value of k, which is 3, so it becomes p is equal to 200 e to the power of 3t. And remember that the population in this case is 4,000, so p is equal to 4,000. And now we just need to solve this equation to find the value of t. So we can divide both sides by 200, which is basically equal to 20 on the left hand side. It's equal to e to the power of 3t. And now we just take the natural log of both sides. So len 20 is equal to 3t. T is equal to len 20 over 3. And that's basically the value of time. So we can obviously approximate this, because remember that t is in years. So we just need to use calculator now and see what is roughly equal to. So this is roughly equal to 0.9985, which means that it's basically like a year. So it takes 1 year for that to happen. And part C, so state a limitation of this model for large values of t. Now this is a very common question, normally one interpretation question. So one limitation is that the population is not going to constantly increase at the current rate, because this is for the population of rabbits, and for example, there are some factors such as maybe food, competition, etc., that they can limit the growth of the rabbits at certain periods, which means that the population is not going to increase in this way forever. So the rate of increase can vary.